I'm going to show you how to use the rational root theorem to factor a polynomial. Now, there are going to be polynomials where you can't use grouping or any type of factoring method that you may have learned before, which is why we now need to use the rational root theorem. So I'm going to walk you through step by step how to use it. First thing we're going to do is list all of the possible roots that we could end up with. So with the rational root theorem, there is a lot of guessing and checking. You need to have patience when you're using the rational root theorem. What you do is, if it's in standard form, you look at your outside numbers. That's how I like to look at it. So we're looking at the first term and the last term. That last term is -8. What I'm going to do is list all factors of 8, including positive and negative numbers. So think of all of your numbers. 1 goes into 8, 2 goes into 8, 4 goes into 8, and 8 goes into 8. Remember, we're also going to include the negatives of all of those numbers. So plus or minus 1, plus or minus 2, etc. I'm going to do the same thing with 2, which is the first term or the first coefficient in my polynomial. Well, the only numbers that go into 2 are 1 and 2. So plus or minus 1, plus or minus 2. Now what we're going to do is we're going to take all of those factors of 8 and divide them by all of the factors of 2. So you're going to take 1, 2, 4, and 8 and divide them all by 1. Then you're going to go back and take 1, 2, 4, and 8 and divide them all by 2. Well, if you're dividing everything by 1, they're not going to change. So 1, 2, 4, and 8 divided by 1 are still 1, 2, 4, and 8. Now we also need to go back and divide 1, 2, 4, and 8 by 2. 1 divided by 2 is a half. 2 divided by 2 is 1, which I already have listed. 4 divided by 2 is 2, I already have that listed. 8 divided by 2 is 4, I already have that listed. So we only had to add the 1/2 to our list. But what I just wrote is all possible roots for this polynomial. So if you have a question that says list all possible rational roots, that would be your answer. Now what I'm going to do is test all of my root, or not all of them, test these rational roots until I get a remainder of 0 using synthetic division. The goal is to figure out my factors. And one way you can do that is to use synthetic division. Once you get a remainder of 0, you know that that number must be one of our roots, which is another word for x-intercepts. So it's up to you what number you want to start with. You can start with whatever number you want from that list that I just made. Let's go with 2 and see what happens. So if I choose to start with 2, again, you can use a different number. You're going to put 2 in the box for synthetic division, and then you're going to go through and do synthetic division with that polynomial. So with synthetic division, I'm going to take down my coefficients. This is already in standard form. I'm not missing any terms, so we're good. Now, my remainder is not going to equal 0 here. I just did it really fast, but that was my synthetic division. So because my remainder is not 0, I'm going to have to try again. That's where all of the guessing and checking comes in. So now let's test 4 instead. Again, you can test whatever numbers you want, but I'm going to go with 4 this time. So I'm going to go through the synthetic division again. We take that number, multiply by the number in the box, add the column, and now we start over. So this time I got a remainder of 0. Now it took me 2 tries here because I've done this problem before and I know what the answer is going to be. But for you, it may take 3, 4 tries. Please don't get discouraged. Eventually you will get a remainder of 0. So I just found that 4 in the box works for me. If I put 4 in the box, that means I was dividing by x minus 4. So what I'm going to do is I'm going to rewrite this as x minus 4 times the answer that I just got when doing synthetic division. Since this polynomial began as a degree of 3, my answer is going to be a degree of 2. So 2x squared plus 5x plus 2. Now you have options. You can either go back to your list of roots from before, and you can do synthetic division again with the 2x squared plus 5x plus 2, or if you already know how to factor what you have left, you can just use whatever factoring method you want to use and go ahead and continue factoring. But these problems are not done until they're completely factored. So I'm going to go ahead and factor this because I know how to factor a trinomial. So if you want to do that as well, you can. Otherwise, you can pause the video and use synthetic division again. So I'm multiplying my outside numbers. That means I'm looking for 2 numbers that multiply to 4 and add to 5. Those 2 numbers would be 4 and 1. Now I've got this 2 in the front that I need to divide back out. 4 is divisible by 2. So I take the 2 out and move it to the other parentheses. And that's my final answer. So from that previous step with the 2x squared plus 5x plus 2, if you chose to use synthetic division again, the numbers that would have worked for you would be -2 and -1/2. So you always have that option. Now, the number that I found that worked first was 4. But if you were doing this on your own and you started with -2, you could have started with -2 and then factored differently later, but you still would have had the same final answer that I did.